In this video, I want to talk about the basic properties of logarithms. So the really important thing we need to remember is that a logarithm is an exponent. We talked about that in another video, but that's the important thing to remember. A logarithm is actually an exponent. So logarithms behave in the same way that exponents behave. So for example, if you have in an exponent, if you have say like 3 to the 4th, or 3 to the 4 plus 2 power. That's the same as saying 3 to the 4th times 3 squared, right? And they're both equal to 3 to the 6th power, right? So they're definitely equal. But this tells us that when logarithms are added, they can actually be multiplied. So for example, if you had log base b of m plus log base b of n, you can turn this into log base b of m times n. The important thing is that the bases need to be the same. So the bases need to be the same here. Okay, now you might remember again with exponents that another law of exponents is if you have, say, 3 to the x over 2 power, this is the same, this should be 3 to the x minus 2 power. That's the same as 3 to the x over 3 squared. So again, we can translate this into logarithms. If we have log base b of m minus log base b of n, we can change that to log base b of m over n. And this is one of the nice things about logarithms. They have a lot of ability to change around, so you can get them to look how you want them to look. So the last property of logarithms is probably the most powerful. So you might remember, again, that if you have a power to a power, so 3 squared to the x power, you can multiply the powers. So it becomes 3 to the 2x. And that happens in logarithms too. So if you have log base b of m to the p power, you can make this power to a power, you multiply the powers. So the logarithm is one power and the p is the other power. So p times log base b of m. And that is how, this is one of the most powerful tools of logarithms, because you can use that logarithm to get a power out of a power and out of the exponent and put it in front as a multiplied term. Okay. So let's actually do a couple of examples. So if we have log base 3 of 14 plus log base 3 of 2, how can we write that as one single logarithm? So we could write, they have the same base, right? So it would be log base 3 of 28. Okay, an example of the second kind would be log base 5 of 20 minus log base 5 of 4, and if we want to write that as one logarithm, they have the same base, so it's log base 5 of 20 over 4, which would be log base 5 of 5, which conveniently equals 1. And that's because if we think about that as an exponential expression, it would be 5 to what power equals 5. Okay, so here we have, suppose that we had log base 2 of 5 to the third power. This would become 3 times log base 2 of 5. And so these properties of logarithms can help us solve equations with those logarithms, and they're very helpful. Let's do one last example. The natural log of 5 plus the natural log of 16 could become, remember these are just logs with the same base, they're both base e, so it becomes natural log of 5 times 16, which would be 80. So that's an example of how you would use it with a natural log. And that's how we use the basic properties of logarithms.